We spent the last 2 years treating generative AI like a sophisticated autocomplete, static, reactive, and confined to a text box. But that initial period of prompt and response was merely a technical baseline. Today, models are becoming autonomous operators. Look at this structural split. On the left, traditional query-based AI synthesizes data into a block of text and stops. On the right, Agentic AI receives a goal, queries your CRM, HRIS, and identity systems, and executes an API post request entirely on its own. These agents operate probabilistically. They do not follow a fixed, deterministic script. They observe the current state of a system, formulate a plan on the fly, and take independent action to reach a defined goal. Handing a probabilistic model direct write access to your deterministic systems of record introduces a severe structural vulnerability. Securing this environment requires a complete security inversion. Teams must stop focusing exclusively on output risk, the fear that a model might generate a toxic response or hallucinate a false statistic. The primary threat profile is now action risk. This is the risk of an agent performing unauthorized database overwrites, initiating phantom API executions, or triggering cascading failures across connected platforms. Traditional prompt filtering and content guardrails offer no protection against an agent autonomously modifying a production database. Scaling agentic AI is no longer a model tuning or data science exercise. It is a strict infrastructure and orchestration challenge. Crossing the threshold into autonomy requires an entirely new architectural layer, or the enterprise faces a collision between probabilistic intelligence and deterministic systems. This blueprint represents the standard legacy enterprise architecture, rigid CRM and ERP systems at the base. Now, look what happens when companies attempt point-to-point agent integration, firing directly from the AI models into those databases. Building single-purpose agents that interface directly with core infrastructure creates a highly brittle, unscalable environment. Disparate agents have opposing objectives. A procurement agent optimizing for cost collides with a support agent optimizing for speed, generating severe friction. To eliminate this, organizations deploy an agentic mesh. This sits horizontally between reasoning models at the top and legacy systems below. The mesh acts as a central orchestrator. It explicitly separates the reasoning capabilities of the model from the actual tool execution and memory storage. This separation is what enables complex, cross-domain workflows. It allows multiple specialized models to collaborate on tasks like automated ITSM account lockouts or insurance claim triage, without directly exposing the underlying databases. Ultimately, it serves as a universal translation layer, ensuring that highly probabilistic requests are normalized before they ever hit your deterministic APIs. The agentic mesh transforms a collection of uncoordinated digital operators into a unified system. Without this layer, agents continue to fight for resources across the network. If we isolate a single agent operating within this mesh, a new problem emerges. How do we definitively authenticate its actions? Traditional role-based access control frameworks collapse when applied to autonomous systems. Static human user roles were built for humans making occasional, deliberate clicks. They were never designed to accommodate an agent executing thousands of dynamic requests per minute. Securing these automated workflows requires implementing identity as the control plane. As seen in this framework, we solve this by architecting AI agents as first-class non-human identities.
Each agent receives a cryptographic identity, linking it directly to an enterprise access control plane. This assignment guarantees end-to-end traceability. Every single database query, read request, and API call the agent attempts is permanently tied to a specific auditable identity. This infrastructure enables dynamic trust scoring. If an agent begins acting erratically, its permissions automatically decay. If it executes perfectly within its bounds, its access can safely elevate. It also forces strict lifecycle management, ensuring decommissioned projects do not leave orphaned agent identities buried in the network as open vulnerabilities. An agent deployed without a defined cryptographic identity is an unmanageable insider threat by default. This leads to the final engineering paradox of agentic AI. How do you physically stop a hallucinating agent from executing a destructive tool in real time? Post-execution auditing is entirely insufficient. Governance must happen at runtime, in the fractions of a second before the system's state is altered. The industry is solving this by building an agent OS, applying the strict resource isolation principles of operating systems to AI governance. Here, an agent fires a tool execution command, but a stateless policy engine physically intercepts that call. It evaluates the request against strict policy rules in under 0.1 milliseconds before allowing it to pass. This sub-millisecond interception ensures that the raw speed of the AI does not outpace the speed of your security controls. We combine this with execution rings. By borrowing from CPU privilege levels, we physically constrain the agent's blast radius based on its current trust score and its validated identity. These OS-level controls directly address the new vulnerabilities outlined in the OWASP Agentic AI Top 10. By enforcing strict capability sandboxing, we mitigate the threat of tool misuse. Furthermore, automated kill switches and circuit breakers stand ready to instantly neutralize any rogue agent the moment it attempts to breach its assigned execution ring. True runtime governance proves that action risk can be neutralized before a single byte of enterprise data is compromised. Now, look at the fully assembled stack operating in harmony. You have the legacy systems at the base, the agentic mesh routing requests, the agent OS validating those calls, identity authenticating them, and finally, the human-in-the-loop approval gate. Within this structure, an agent can safely handle thousands of low-risk tasks autonomously, discovering data, mapping schemas, and parsing documentation without human oversight. It can perform complex entity resolution, preparing the exact parameters of a critical transaction for final execution. But that fast-moving workflow hits a hard stop right here. The system pauses entirely, waiting for manual human authorization before executing any write command to a core system. High-stakes, consequential decisions, financial transfers, core policy modifications, or bulk data deletions must always default to a human authorization gate. The architecture demands it. IT leaders now face a strategic choice in how they build this out. The first path is incremental integration. Here, the agentic mesh is bolted onto existing legacy cores, acting as an augmentative layer modernizing operations over time. The second path is comprehensive transformation. This requires a ground-up rebuild of a native agent architecture, demanding heavy upfront investment to secure maximum competitive agility. Competitive advantage will belong to organizations that stop treating AI as a software feature and start treating it as a